So we're going to choose CALCEQ1, which is the third in this menu of programs. And then here you're going to see the basic main menu. We have basic derivatives, trig derivatives, inverse trig derivatives, miscellaneous derivatives, some basic reminders about derivatives and integrals, which is a full integral menu. But let's walk through this slowly. So the basic derivatives, and we're going to assume A is f of x and B is g of x. I did that because otherwise things wouldn't fit on the screen. So the derivative of the constant 0, you know that. Derivative of just simply x is 1. We can take out the constant of an x expression, like derivative of c of x is c. And then, then we start going into, power rules and then addition and then multiplication, a prime b plus ab prime, and then division b prime a minus a prime b over b squared. Remember, assuming a is f of x and b is g of x. And then the derivative of the absolute value of u is u divided by the absolute value of u, all that times u prime. Okay, and then walking through the trig derivatives, derivative of sine x is cosine x. Derivative of cosine is negative sine, et cetera, et cetera. And remember, if you do have a u, it's going to be times that u prime, but I have that in the reminder section, so you'll see that in just a second. Let's do the inverse trig derivatives. Now, I know this is old style nomenclature, the arc sign rather than saying sine to the negative 1 of x. If you'd like me to change it, please comment. I will change it in CALCEQ2 in an updated version of this. I just put arc sign because I know that's a holdover from days of yesteryear. But that's 1 over rad 1 minus x squared. And then we go on for inverse cosine, inverse tan, inverse cosecant, inverse secant, and inverse cotan. And again, we've got the absolute value bars where necessary. Okay, and then we choose option 4, miscellaneous derivatives. I put these on here because I've seen students at a loss when they see what's the derivative of ln of u or what's the derivative of a dx or a du. So we got the derivative of ln of u is u prime over u. You guys probably already know e to the u is e to the u times u prime. And then if we have derivative of a to the x, it's going to be ln of a times a raised to the x. That's going to be when you have an x or another expression in the exponent. So it'd be ln of a times a to the u prime when it's a raised to the u power. Now, I'm trying to express the best I can. When you have log base a x, the derivative of that would be 1 over ln of a times x. And the same thing if I have log base a u being an expression. So it'd be u prime divided by ln of a times u. And then I just want to put this reminder here because I know this was difficult for me going through calculus the first time. Derivative of sine x is cosine x. You already know that probably. But derivative of sine u is cosine u, but then times du. Because remember, if it's like sine of 3x, derivative would be cosine of 3x, all that times 3. Actually, even better to be having to written it, as 3 cosine 3x. But let's go now to the integral portion. So we have the basic integrals. Oh my goodness, there's a lot, integral of c of f of x dx times dx, sorry. We can pull out the constant and then just the derivative, the integral of 1 over x dx is ln of x. And then also, you have that u thing. If it's 1 over u, it's going to be ln absolute value of u, I think, times, but it have to be du here. Integral of du is u plus c. We have x to the n. Now you guys know this as, like x, derivative, say like x cubed would be x to the third divided by 3 plus c. And then if we have integral of f prime of x over f of x, we have ln absolute value of f of x plus c. Integral of f of x times g of x is big fx. Now you guys know the difference hopefully between integrals and derivatives now, but we got this going on here. And then we got the integral of f of x plus or minus g of x is going to be the integral of f of x plus or minus integral of g of x dx. And then for integration by parts, integral of u dv is vu times integral of v du. We could have made that, sorry, that's uv. My English is bad. It's my first language. Okay, and then we go to integrals again. And then we could do some trig integrals. So integral of sine x is negative cosine x, yada, yada, yada. And they got tan, cosecant, secant, cotan, replete with the natural logs and the absolute value bars were necessary. And then the cool thing about the secant squared, cosecant squared, secant u, tan u, cosecant u, tan u, or cotan u, sorry. And then we go on. And then let's do the integrals once again, maybe actually a couple more times. And then the inverse trig ones. So integral of du over rad a squared minus u squared is arc sine u of a plus c. And again, if you're unfamiliar, arc sine is like saying inverse sine. And then the integral of du over a squared plus u squared, 1 over a arctan or inverse tan u over a plus c. Same thing with integral of du over u rad u squared minus a squared. I should have closed another parentheses here, but that's going to be inverse secant or arcsecant absolute value of u over a plus c. And then more integrals, right? Let's do the exponentials. Now, again, some of these are not exponentials. Some are logarithmic. I just couldn't fit that on a line there. But we've got this. I'm sure you've seen this before. And again, we've got the cosecant, secant, and cotan with the ln's and whatnot. Okay, just want to include that because those have logs in them. But if you have ideas for improvements on this program, please put in the comments. That's how we get ideas to make new programs and improve programs. But again, this is all available at mcstutoring.com. As M is in Mary, C is in Charlie, S is in Sam, mcstutoring.com as CALCEQ1. Good luck in all of your math endeavors. See you next time.